So for this question, they said at the instant WA is equal to 5 rad per second for pulley A, and the constant for acceleration is A of A is 6 rad per second square. So let's start with the first triangle. So omega, the at the instant means the initial. So the initial angular acceleration at A is 5 rad per second. Don't forget to bring your 5%, but for time, I won't bring it. So A, the angular acceleration for A. So, sorry, the angular acceleration for A is 6 rad per second square, rad per second square. So, we saw for our question. So, when you want to find for the final angular acceleration velocity for A, you get it from the normal equation, which is this. Notice for this one you set angular constant angular acceleration. That's why you use this formula. So you look for your final one by putting this preamble inside this. But the angular position was given in revolution, so you have to convert it to rad. One revolution is equal to 2 pi rad. So one rev is equal to 2 pi. So if I want to find for 2 revolutions, it will be what? 4 pi. It sets the position inside, but notice the initial distance is 0. So when you solve, you get the final angular velocity for A as 13.2588 rad per second square. So now, since pulley A is attached to pulley C, so that means the velocity for A is the same as the velocity of C. So let's look for the angular velocity for C. So the velocity formula in rotation is omega r is equal to omega r. But this one, the omega r, the first one is for A, and the other one is for C. So when you set the parameters inside, you have already found for the angular acceleration for A, which is 13.2588. Then multiply it by the radius. The radius is here, as you can see. Convert it to meters. So it will be 13. So omega c, what is the radius of c? You can see that the radius of c here is 40 millimeters, which is 0.04 meters. 0.04. So you don't have to do this. So 0.04. So when you simplify, you get omega c as 16.735 rad per second. So rad per second. Well, you can see that they said in the question B on A. That means B is on B on C, please C. So that means the angular velocity for C is the same as the angular velocity for B. So if you want to find for the angular acceleration, but here we can see that B is on the tangential one, which is here, and also for the normal, which is here. So for us to find the acceleration, we have to find for the angular, the acceleration for tangent and acceleration for normal. So we have from the question, they have already given us the angular acceleration for A. So we can look for the angular acceleration for C and equate it to B since they are equal. So the angular acceleration for the tangential is equal to the angular acceleration times r. So acceleration to tangential is equal to this. So the angular acceleration of A R A is equal to the angular acceleration for C R C. Then you put your values inside. You can see that C is 40. So when you put the values inside, you get angular acceleration for C to be to be 7.5 rad per second square. So now, since C, I said angular acceleration for C is the same as B. So we find for the acceleration, the tangential acceleration. So, which is equal to 7.5 times the radius of B, which is 60, and is the same as 0.6, 0.06. So you get your acceleration for B to be 0.45. Now then we look for the normal acceleration, which that one the formula is A for B, so AB for the normal is equal to omega square R. Omega square R. But from the previous question, we got our omega for C to be 16.735, and I said C is the same as B, so 16.735 square times the radius of B, which is 0.06, and you get your answer as 16.480. So we got our acceleration for B at the normal part to be 16.4809 meter per second square. So if we want to find for the magnitude of A, we find for the square root of these two variables. So it will be square root of the acceleration for the tangent square plus the acceleration for the normal square. Then put your values inside. So you put your values inside, you get the square root of 0.45 square plus 16.480 square. So your magnitude for the acceleration at B will be 16.5 meter 5 meter per second square. So 15.5 meter per second square, 5 meter per second square. The units are very important. So we are done solving this question. Thank you.